Hello students, I am Kausalya. Today we are going to solve part 4 of example 1.10. That is, now we are going to draw force current analogous circuit. So these are the general expressions, that is differential equations of mass m1, mass m2 and mass m3 are respectively written here. Here the displacement is replaced by velocities, right? So from this equation we are going to obtain our force current electrical analogous circuit. So the first thing is, here m1 should be replaced as c1, so m1 as c1, m2 as c2 and m3 as c3. And here b1 is replaced as again 1 by r1, 1 by r2, 1 by r3 and b23 as 1 by r23. And the next one is, here we are having k1 and this k1 should be replaced as l1, so 1 by l1 and here 1 by l, k23 should be represented as l23. And the next one is v1, v2 and v3 remains as such, right? So this is our force voltage analogous circuit, and from this force voltage analogous circuit we are going to draw the force current analogous circuit. So as I already said, the thing which are to be replaced is inductor should be replaced by a capacitor and capacitor should be replaced by a resistor. This is a short trick, right? So here now we are going to replace inductor with capacitors and capacitors with inductors, and the resistors will remain as such. This is the first criteria. And the second one is, the elements which are connected in series will be drawn as elements in parallel in our force current analogous circuit. Right, this is our force voltage analogous circuit, and now I am going to draw the force current analogous circuit. So here in this case, again as I already said, these three elements are in series, right? So now I am going to draw these three elements in parallel, and the next thing is, here we are having three loops, loop 1, loop 2 and loop 3. So in our force current analogy circuit we will be having three nodes, okay? One is V1, another one is V2 and another one is V3, okay? Let it be V1, V2 and V3, right? So the first step is, in our loop 1 we are having this L1, R1, C1 in series. Now I am going to draw these three elements in parallel. So as I already said, this inductor should be replaced by a capacitor. So first I am drawing a capacitor here. Okay, capacitor C1. Next one I am having resistor. So resistor remains as such, no change. So just draw a resistor like this. Next one is, we are having capacitor and this capacitor should be replaced by an inductor. So just draw an inductor in parallel, right? And the next one is, here listen carefully, I am having this resistor R3 and this R3 is common for loop 1 and loop 3, right? So in this case, between your node 1 and node 3, just here for resistor, this resistor will always remain as such. So no need to change anything. So just draw a resistor between your node 1 and node 3. So let this resistor is R3, right? So here C1 and it is R1 and this is your L1. And the next one is, we are having R2 and this R2 is common for loop 1 and loop 2. So here we have to draw an R2 which is common for your node 1 and node 2. So here just draw a resistor R2 and this R2 is common for node 1 and node 2. So here from this, just directly connect this to your node 1, right? So in the first loop we are having totally 1, 2, 3, 4 and 5 elements, right? Again to this node 1 also you should have 5 elements to be connected. So just count the elements now. We will be having 1, 2, 3, 4 and 5, right? These things get satisfied. The next one is, move to your loop 2. So to this loop 2, here we are having an R2. This R2 is already drawn here, okay? So just you can neglect this one. And the next one is, here you are having a resistor in series with the capacitor, right? And these two elements are common for your loop 2 and loop 3. So now you have to draw these two elements, that is resistor will remain as resistor and this capacitor should be replaced by an inductor. And these two elements should be parallel. So here in this case, just draw a resistor as such. And the next one is here capacitor should be replaced by inductor. So just draw an inductor in parallel, right? So this is your R23 and this is your C23, right? So the next one is here you are having an inductor L2. So this inductor should be replaced by a capacitor. So here since this inductor belongs to your loop 2, so this inductor should be get connected with your node 2. So this inductor is nothing but a capacitor here. So just draw a capacitor C2, right? So just now count the number of elements connected with that are present in your loop 2. 1, 2, 3 and 4, right? Similarly, to this node 2, you should be having 4 elements connected. 1, 2, 3 and 4, okay? Right, that's it. And the next one is, just count the number of elements which are present in your loop 3. So in this loop 3, you are having 1, 2, 3 and 4, right? That is R3 is present. So to this node 3 we are having R3, that is the R3 is drawn already. And the next one is we are having R23 and C23 and this R23 and C23 are already drawn. And the remaining thing is we are having an L3 and this L3 should be replaced by a capacitor C3. So to this node 3 just draw a capacitor C3, right? And here also to this node 3 you should be having 4 elements, right? 1, 2, 3 and 4. So here also 1, 2, 3 and 4, right? That's it. This is our force current electrical analogous circuit. Hope you all understand this very well. Now we are going to write the respective equations for each and every node, right? So at node 1, so the current flowing through this, we have to write it as the current flowing through the capacitor is, it is nothing but 1 by C1 into integral of I1 into dt. Plus again, the current flowing through this resistor should be, this is force current, right? Sorry. Regarding this force current, we have to write each and everything in terms of current, that is in terms of voltage. So we have to write it as C1 into dV1 by dt. Plus again this one is current flowing through this resistor is V1 by R1 and again current flowing through this inductor is 1 by L1 into integral of V1 into dt. And the next one is we have to write expressions for this R2 and R3, right? So for this R2 we have to write it as V1 minus V2 divided by R2 plus, and for this R3 it is connected between V1 and V3. So we have to write it as V1 minus V3 divided by R3 and this is equal to 0. Okay, this is your equation number 1, right? And next one is at node 2. So at node 2 we have to write the expression. So for writing node 2, here for R2 we have to write it as V2 minus V1 divided by R2, right? Plus again for this capacitor C2 we have to write it as C2 into dV2 by dt because this is connected to V2. And the next one is here R23 and C23. So we have to write it as V2 minus V3 divided by R23 plus again for this capacitor I have to write it as C23 into d by dt of, again this is connected between V2 and V3. So here we have to write it as V2 minus V3 which is equal to 0. Okay, this is your node 2 equation. Now I am going to write your node 3. So at node 3 as usual just write here we are having C3. So C3 into dV3 by dt plus, and the next one is again for these two we have to write expressions. So this one V3 minus V2 divided by R23 plus, and for this C23 we have to write C23 into d by dt of V3 minus V2 plus, and finally we are having R3. So for this R3 we have to write it as, this R3 is connected between V3 and V1. So here we have to write it as V3 minus V1 divided by R3 is equal to 0, right? These are all the respective nodal expressions. That's all. The problem is over here. Hope you all understand well. Thank you.